The other day I was watching one of my favorite TV shows, Red Dwarf, and on this particular episode there was a missile called the Photon Mutilator. Now that is really cool looking. I gotta build one of those. But will it fly? Let's find out. Now there's not a lot of video where we can clearly see the Photon Mutilator missile, and when it is clear, it's difficult to make out a lot of detail because essentially it's a black missile with a black space background behind it. So I gathered as much information as I could from the video and headed over to OpenRocket to put in the design. Let's take a look at what I've got. So here's the basic rocket design in OpenRocket. If we look at it in the photo studio, it looks pretty nice. It's a pretty good rendition of the actual Photon Mutilator in the TV show. But there's a serious problem with this rocket. OpenRocket shows that it has a stability factor of negative 0.33, and that's pretty bad. And if we run a flight simulation on it, OpenRocket brings up this message in the bottom corner that says, "Simulation aborted, stage began to tumble under thrust." So basically, OpenRocket is telling us this is just not a stable design. It's not going to fly. We've seen that same problem before when we try to build rockets out of things that we've seen on TV shows. For instance, our D3 missile that was from an old Godzilla movie. This is a scale model. I didn't make any design changes. It looks great, but it has some serious stability problems. And then our P1 rocket that was also from an old Godzilla movie. I had to make some significant design changes to this in order to get it to be a stable design. So this Photon Mutilator is going to be the same issue. We're going to need to make some design changes in order for it to be stable. So let's take a look at the new design. So here's the new design in OpenRocket. If we take a look at it in the photo studio, the first thing you'll notice is that it's a lot taller. So let's take a look at a comparison view of the original design compared to this newer design. So to make the rocket taller, I increased the length of all three sections of the body tube. I also increased the length of the transition pieces that transition from the 4-inch body tube down to the 3-inch body tube. I increased the size of the fins. And then the last really significant change is that I moved the rocket motor a couple of inches up into the rocket. Now I'm not super excited about having the motor pushed that far up into the rocket. I have a couple of concerns with that design, but it does have a significant impact on flight stability. So for the moment, we're going to leave it in that position. After we get all the weights of the different parts of the rocket put into the software, I'll look to see if we can move the motor down a little bit and still maintain a good stability. Now that we've got the basic rocket design finished, I'll use Tinkercad to design all the parts that need to be 3D printed. The first part here is the fin, and this also has this rectangular box piece here that mounts onto the body tube. And then out at the end of the fin is a fin pod with the point on the top of it. All the leading edge surfaces are either beveled or pointed to help this cut through the air nice and efficiently. This design came out really nice. The next part is the nose cone. I really like how this decorative part came out at the top. Now this is our apogee nose cone system. It's going to have the flight computer installed inside. We'll talk about that a little bit more a little bit later in the video. And then we've got the two transitions. These are the pieces that adapt the 3-inch body tube to the 4-inch body tube. The last piece is this tapered part that goes at the bottom of the rocket. Now this is just strictly decorative. It's just there to make the rocket look like the missile that we see in the TV show. So now we're ready to 3D print the parts. Here are the parts we'll need to build this rocket. I've got 2 lengths of 4-inch diameter cardboard tubing and 1 length of 3-inch diameter cardboard tubing. I've got a bulkhead. The motor will be pushing against this, and the parachute cord will also be attached to this. There's a cardboard sleeve that gets glued in on top of the bulkhead so that it doesn't get ripped out of place when the parachute ejects. There's 2 motor centering rings. The upper motor centering ring goes in the 3-inch tube, and the lower motor centering ring goes in the 4-inch tube. And then there's 2 rail buttons that will allow the rocket to slide onto the launch rail. Now the 3D printed parts. First we've got the nose cone. I really like how this decorative piece came out at the top. This is printed extra thick and it has a 50% infill. So this is actually a pretty heavy nose cone. That's one of the features that I'm using to help balance the rocket and improve the stability. Now this is our apogee nose cone system, so it has threads in here. This base piece will have the flight computer installed, and that screws into the bottom of the nose cone like that. And then we've got the 2 transitions that go from the 3-inch tubing to the 4-inch tubing, the upper and the lower transition. And then there's just this decorative beveled piece that goes at the bottom of the rocket like that. And finally we have the fin. Now a couple features on this fin. This rectangular mounting piece here is hollow. So I'm hoping that will act a little bit like a tube fin and assist with stability. Also, this pod at the outside is also hollow, so I'm hoping that will also act a little bit like a tube fin. All the 3D printed parts here took about 85 hours to print. So now we're ready to build. But before we start assembling this rocket, let's put it all together and just see what it looks like. So there's the finished design. It looks pretty good, but just looking at it, it kind of occurs to me that it looks like the fin is a little bit small. Now, it's not a bad fin design, but I'm wondering if we could make the fin a little bit bigger, either taller or wider, and maybe assist with improving the stability of the rocket, now would be the time to do that. I've only printed 1 fin, so now would be the time to change the design before I get them all printed out. So let's go over to Open Rocket and see if we can make any modifications to this fin that might make it look a little bit better on the rocket and also improve stability. Now, if we just increase the height of the fin by ½ an inch, I think it actually looks a little bit better on the rocket, but unfortunately, that has a negative impact on stability. Our stability has gone down, and I'm not willing to make any changes to the fin that's going to decrease our stability. So we can't make the fin any taller. Let's try making it longer, basically stick out from the rocket an extra ½ an inch. Now, if we do that, it still looks really good on the rocket, and it does actually increase our stability. Now, because of that increase in stability, I'm going to actually move the rocket motor down closer to the bottom of the rocket by another ½ an inch. And we still end up with a good stability. So we're going to go ahead and make those fins ½ an inch longer and see how that looks. And there's the new fin. It's exactly the same as the previous one, it's just ½ an inch longer. Now, after I got this 3D printed, something occurred to me. This is a surface mount fin. Now, it has a large surface area here, but it still is a surface mount fin, which means it simply gets glued to the side of the cardboard tube. I don't like surface mount fins. Now, I don't know why it didn't occur to me earlier, but I'd like to do something different to this design to give it a little bit more strength than just simply gluing to the surface of the paper. So I went back into Tinkercad one more time and made a couple of changes. Here's the new fin. Now it's exactly the same shape and size as that one that we just printed, but I made 2 changes. First one is that I added this little hook piece on the inside here where it mounts to the cardboard tube. So we'll make some slots in the cardboard tube, and that will hook into the slot, and we'll be able to put some adhesive on the inside, so that will just act as a little bit reinforcing anchor to help strengthen that fin installation. Now, at the same time, I decided to make another change that I've been thinking about doing. On this mounting base piece here, I rounded the corners. On all the previous designs, it had 90-degree corners. The rounded corners just look better, and it looks a little bit more like the corners that are on the original Photon Mutilator missile. So I really like this new design. I'm going to go ahead and print the other three. Now this rocket is different from other rockets that I've built in the past, so we need to really be thinking about the order of operations. That's basically the order in which we assemble the rocket. We don't want to accidentally glue some part in place that then prevents us from gluing some other part in place. So normally I would work on the base portion of the rocket with the fins and the motor centering rings and the bulkhead, but we can't do that on this particular rocket because of a problem I discovered with the transitions. The transitions have this nice shelf where it fits onto the 4-inch tubing, nice and firm. It doesn't have that same shelf where it transitions to the 3-inch tubing, which means that the 3-inch tube has some play. And we have that movement down here, and we also have that same movement up at the top where it transitions here. So we need to work on getting all of the body tubes and the transitions aligned and glued in place pretty early on in the assembly of this rocket. Now before we glue these parts in place, we do need to install some parts into the 3-inch tubing, because once we get that glued onto the transition, we won't be able to get those parts inside. And those parts are the upper centering ring, the bulkhead, and then the bulkhead retaining ring. So for the motor centering ring, I've got this little piece here that we 3D printed for another project. It holds these centering rings nicely. Now this is 1.75 inches tall, and we need to hold the centering ring 2 inches high. So I've just got a little 1/4 inch spacer, and if we position it like that, that will position the centering ring 2 inches up in the tube. While we wait for that adhesive to harden, we can attach a length of paracord to the bulkhead. The reason we need to attach this now is because after the rocket is built, we won't be able to reach down and attach a paracord to this later. So I've drilled 2 holes in the bulkhead, and I have 9 feet of 2mm paracord. Now you might be wondering why I installed the paracord near the edge of the bulkhead rather than in the center. And that's because this is also the motor stop. The motor will be pushing against the bulkhead like that. So we want the paracord away from the center so that it's not where the motor is coming in contact with it. So this is ready to install in the 3-inch cardboard tube. This gets glued in 3 inches up from the bottom of the tube. So for that, I have a piece of PVC pipe cut exactly 3 inches long that fits up through the upper centering ring. And then we can just slide this down and position it on top of that PVC pipe. And then with that in place, we'll glue in the retaining ring on top of that. Now that we have those parts glued into the 3-inch body tube, we're ready to assemble the entire body section of the rocket. I've got something out in the shop that'll help us keep this aligned while we glue it together, so let's head out there. I'm going to use the surface of the table saw to align these parts while we're gluing it together. The table will keep the parts aligned in this direction, and the fence will keep the parts aligned in this direction. So as long as we keep all the parts pushed against those surfaces while we're gluing it, everything should be nice and straight. So let's get this assembled here. Now to keep those in position while the glue is drying, I've made these little braces that will apply some pressure onto the 4-inch parts, and it kind of pushes it at an angle so that it's pushing it both against the table and against the fence. And then I've got these little weights that will just sit up there to apply some constant pressure while the glue is hardening. So let's go ahead and get all of those connection points glued together. Now that I've got that glued and held in position, I've got these little 1/2-inch MDF spacers. Now because the 3-inch tube is exactly 1 inch smaller in diameter than the 4-inch tube, these 1/2-inch spacers should fit perfectly behind and underneath the 3-inch tube. That will ensure that we've got that 3-inch tube perfectly aligned the way we want it, and the 4-inch tubes are aligned because they're held against the table and against the fence. So I'm going to let this sit for at least 12 hours for that adhesive to dry before I touch this. That came out fantastic. Now there is a little bit of gapping between the transitions and the 3-inch cardboard tube, so I'm just going to apply a little bit of construction adhesive in that area just to provide a smooth transition between all the parts. Now we're ready to install the fins. Now we need some type of a system to identify where the fins are located and an alignment system to make sure that the fins are all aligned. So here's what we're going to do. I'm going to start out with a fin alignment template. This gets wrapped around the rocket and it has several markings on it that identify the left and right sides of each fin, and also a mark where the center of each fin is located so we know where to cut the slot for the little fin tab. Once we get all those markings on there, we'll use this alignment base. Now this is the alignment tool that we used when we made our P1 rocket, and it's perfect for this rocket as well. It has a ring on the center that allows you to place a 4-inch cardboard tube down onto the center of that. And then there's simply 4 lines that extend out that show you where the fins are to be located. Once you get the fins installed, you simply sight down each one of the fins to make sure that it's aligned over the line, and if you need to make some fine adjustments, you can do that before the adhesive hardens. So let's get started. Now that we've got those marks drawn, we need to extend those lines all the way down the length of this portion of the rocket body. I've marked the locations for the fin tab that goes through the body tube. I'll pre-drill that with a small drill bit, and then we'll use a side cutting bit or a milling bit to cut the slot. Since we need to glue together several parts at the same time, I'm just going to do a test fit on the fins to make sure I don't see any problems with the fin installation. Wow, that looks great. I really hope this rocket flies because this just looks really nice. Let's see what it looks like with the nose cone on. Yeah, that's fantastic. Well, I don't see any problems with that fin installation, so let's go ahead and get those glued in place. This is looking really good. Next, I'm going to use some quick setting 5-minute epoxy to seal the transition between the cardboard tube and the fin base, up the side of the fin, along the top, and back down the other side. That's going to provide a nice smooth transition between the parts, and in some areas there's some little tiny gaps between the two pieces, and this will help fill that. And to complete the fin installation, I'm going to apply some adhesive on the inside around those little tabs that stick into the cardboard tube. Next, I'll install the upper rail button. Now, both rail buttons are going to go on this lower body tube, and I want the upper rail button to be as high up as possible, so I'm going to install it just under the transition. Before we install the lower rail button, I need to install the lower motor centering ring. This is installed 3.5 inches up from the bottom of the tube. So I've got a little spacer here that holds the centering ring. That's 3 inches tall, plus a 1/2 inch spacer will hold it exactly where we need it to be. Now we're ready to install the lower rail button, but before we do that, let's take a look at how we're going to hold this tapered piece on the bottom of the rocket. We need this to be easily removable because we need this out of the way in order to install and remove the motor. So I'm going to secure this in place with 2 screws. The rail button already has a screw, so we're going to use that to secure that over here, and then on the other side I'll install another screw. That will secure that piece in place, but also make it easy to remove for the motor installation. Now at this point, the rocket build is basically finished. It needs a good paint job, and we'll get to that in just a minute. But before we do, I wanted to talk about the nose cone. As I mentioned earlier, this is our apogee nose cone system, so there's a large cavity in the nose cone and threads along the bottom. We have this base piece, and installed on that is the Egg Timer Apogee flight computer. Our ejection charge also gets attached to this, and that screws into the bottom of the nose cone, and that's where the electronics are located. And for recovery, we're going to be using our 38-inch ripstop nylon parachute. So let's get a good paint job on this. And here is the finished Photon Mutilator rocket. This thing came out awesome. Now, if I was going to build this again, there's one little change I would make, and that's the thickness of the fins. When the project first started, the fins were a lot smaller, and that's when I determined how thick they would be. But as the project evolved, they got a little bit bigger, and I never changed the thickness of the fins. I think if they were thicker, they would look a little bit more like the missile on the TV show, and they'd certainly be a lot stronger. But other than that, this came out just fantastic. Now I'm going to get this fully loaded up with the motor and the parachute and the other internal parts, and we'll see what the launch weight of this rocket is. And here it is, ready for launch. The drogue parachute, the flight computer, the ejection charge, all installed up there. The motor is installed, and it's several inches up in there, and I am still concerned about the location of that motor, but we'll just have to wait and see. Now, an issue came up when we were getting this ready. We were originally going to use our 39-inch diameter parachute, but once I realized just how heavy this rocket is, I had some real concerns about that size parachute. This rocket is about 60% heavier than the rocket that we normally use with that 39-inch parachute, so I was real concerned about the descent rate. So thankfully I was able to fit our 54-inch parachute into the parachute bay. So that's what we've got in there, is a 54-inch diameter parachute, which should give a great descent rate for this rocket. So the total launch weight of this rocket is 1,529 grams. The Photon Mutilator rocket is ready for launch. So first off, I want to say that was one of the best rocket launches we have ever done. The rocket came off the launch rod perfectly straight and continued straight as an arrow through the entire flight. It reached 1,066 feet or 325 meters. Ejection, parachute deployment, and descent, all perfect as well. Now, having the motor up inside the rocket a couple of inches really didn't seem to have any effect. It worked perfectly fine, and there's no damage to this cone piece on the bottom of the rocket either. But unfortunately, we did break one of the fins when the rocket landed. I'm not too surprised, because I really feel that these fins would have been better if they were a little bit thicker and therefore a little bit stronger. But there was one other thing about the rocket that we noticed as we examined it. One of the fins was warped. Now, it turns out that PLA has a real problem with warping in the heat, and it was pretty warm that day. The rocket was in the sun and it's black, so obviously it was absorbing heat and getting hot. Now, I don't know if that fin warped when it was sitting on the launch pad, or if it warped during the flight, or could have warped as the rocket was descending. Something else interesting happened. When I got home, I didn't empty out the vehicle, so the rocket sat in the vehicle in the sun for a couple of hours before I got to it. And when I did finally take it out, I noticed that all 4 of the fins are pretty badly warped. So PLA definitely has a problem with warping in the heat. I did some research, and it turns out that PETG is a better option for something like this that's going to be used outdoors or in the heat. Now, I've never used PETG in my 3D printer, but I'm going to get a roll of that and try it with the next 3D print that we do for fins. So this was a one-time use rocket. It was really fun to build, and it came out spectacular. I hope you enjoyed the video. Make sure you click that like button before you leave. We really appreciate it. Check out the full line of rotary rocketry merchandise. There's a link to our shop in the description. And also check out the link to the new rotary rocketry plushie, handmade by my wife right here in the USA. Thanks for watching. We'll see you next time.